My name is Lars-Inge Sjöqvist. I am the CEO of Gapwaves. Let's see here if we can start the presentation as well. So, yeah, the company has been around for a while now. We started 2011. It was a professor here in Gothenburg, Simon Kildal, who started the company. He was an inventor of the technology as well. So it's really his invention we are building the company on. And it's about doing what we call waveguide solutions for antennas. The company is very much around antennas, but the invention is mainly for how to really produce high volume for this kind of waveguide antennas, which is a little bit different from what we normally use today. To found the company, we listed us 2016 and at Nasdaq First North. Today we have around 8,000 shareholders, so it has been a big interest for our company. And this is also a way for us to really see that we can broaden our communication about the company. It's based on patents, of course, then, as it is inventions, and we still have a number of new patents as we apply for every year. That's the way for us to protect us against competitors who are interested in the same kind of technology. And more specifically, we are working with what we call waveguide antennas, and mostly this is for what we call radar solutions, radar for cars, radar for trucks, but also for communication equipment like telecom. So this is the two main areas we're working in today. And really we are unique in that sense that we are the first company coming with this kind of technology, which can be produced in high volumes. And this is the key. And the problem has been for a while. It's doing waveguide is nothing new, but it has always been very tricky to make them in, because they need a high precision and it's very difficult to make them in high volumes. Today we are around 30 employees in the company and growing. What is this technology about then? What you see on this slide is two different versions of a waveguide solution. The first one is the classical one. Then you have to make what we call a rectangular waveguide in a metallic piece, like you can use aluminum or something else. But what is happening when you put on a top on that is that it's very difficult to get it tight enough in the normal kind of production. This means there will be leakage, and that is what you absolutely want to avoid. So using our technique, you see in the bottom in the slide, we have pin structures, and this is also called a meta surface or artificial magnetic conductor, AMC surface. These pins make a wall, even if it's not physically sealed. But as you can see on the simulations we see here, there is no leakage, even if there is a small gap in between the pins, but also in between the layers. So this is a very, very robust way to produce this kind of waveguides. And that's the magic thing with Gapwaves, really. Talking some word about these different frequencies, because that's also important for us. If you go up in frequencies, as we do mostly of the time, it's more and more difficult to use what we call a PCB-based antenna, which is the most common thing used today. In your telephone, in the telecom systems, normally we are working on up to 3 gigahertz, I can say. In these cases, you don't really have a need for the antennas we can make in the Gap technology. But if you are, as we see here for the automotive industry, which is a global standard as well, 77 gigahertz is what they are using for radar. That means then you have a very big loss if you go up in that kind of frequency. And that is a demand today because it's a standard and everyone needs that. And if you should make antennas here, it's very difficult to use something else than just waveguides. So in these cases is what drives us quite hard today to produce and to develop pieces or antennas for the automotive industry, but also some other areas around that. I will come back to that a little bit. Products we have today is in the automotive radar segment. Typically, you see one here for a classical, we can call it a corner radar solution. It's a 40 by 40 or 50 by 50 millimeter solution for an antenna. And other things is what we call radar verticals, is also for use in what we call imaging radar. More channels means more resolution, more possibilities to detect things outside or in the range of the radar. And you can also have longer range. That means we do things for what we call radar verticals. That could be typically robotaxis, it could be drones, etc., which also are interested in this kind of solutions, having radars as a sensor. And then the last piece is the 5G, the telecom, or 6G. When we go up higher frequencies in this area, the antenna solution will be more and more challenging for using what they call a classical PCB. Then you need to go over to waveguide antennas in more and more solutions. So our time is to come really much in that area over, maybe 2025 or something. We will see more and more of these 5G solutions or 6G solutions, I guess it will be the name of it, when you need higher frequencies. And the reason for going up in frequencies could be worth mentioning is that you normally get, or you will get a lot more bandwidth, meaning that you have a lot better performance if you talk telecom, if you go up in frequencies. But it's more difficult to produce things on higher frequencies. That's the reason it takes some time. These different areas we work in, automotive, typically we see drivers here as Euro NCAP, that is organizations which regulate how you can classify different cars in the safety requirements. And there is also autonomous vehicle, meaning that they can drive more and more themselves. So there we see typically a number of tier ones. We have Hella as a customer. Their competitors around could be like Bosch, Continental, ZF, Veoneer, etc. Veoneer is also a customer to us. But of course, we work in this segment, and in this area, there are a huge number of volumes. Talking about radars in cars, we understand that there will be a number of them in each car, meaning that this will grow dramatically over time now. Next vertical, you typically see other kind of companies. It could be like Under, as we work with, but you also have like SmartMicro doing what they call a traffic management solution, meaning that you should detect things in a junction on a road to see how much cars in each lane, etc. So you can make a very smooth transition in every joint in between different roads, for example. This is coming more and more, and it's also based on what they call smart city. Robotaxi is another area, which also we can see a lot of activities going on. And a number of these companies are really asking for better solutions for radars. So they are developing new radars themselves, and they are also asking for antennas to make that happen, which is for us quite interesting, and also meaning that we meet a number of very, very big companies today, that's for sure. So coming from Gothenburg with 20 or 30 people is a quite interesting challenge, really, to meet these huge, big opportunities on the market. In the telecom segment, we typically see Nokia, Ericsson, Samsung, NEC as the main players for doing the infrastructure for telecom. And these, they all knows about us, but still they don't really have the need for our technology fully. So we are just in a waiting mood with most of them today. Something back to the radar side, talking about a sensor in a car. This customer has really made a test with going from a PCB antenna and switch over to a waveguide antenna from us. And they have measured the difference, and you can see here it says like 5 dB in difference on this 77 gigahertz radar. That means a lot in broader view, reduced size, or higher resolution if you want to use it, the difference in different way. dB is, in this case, like 3 to 4 times more performance you can reach from there. That's the difference. So it's huge. It's a lot of value for the customer in performance. And talking about something, what is called as these different levels, it's coming from SAE. They look at the number of sensors and how different cars will be working over time. And there are up to 5 levels in how to become more and more autonomous as a car. And yes, you see here, just to illustrate, you can see the number of radars expected to be in different levels. And there is not only radars, of course, we do have cameras and lidars in these kind of cars. But the number of radars is probably the one which will be most in the car in the end, if they should be fully autonomous. And the reason for that is really that it's a very robust solution. The radar is not really impacted of light or snow or fog or things. It can work in many different environments and has a robust way to attract also the automotive industry, and then not at least the safety in these cases. On the imaging radar side, we have a customer called SmartMicro. They are a German company. They are selling radar equipment for typically how to handle the junctions in a road system to make it more smooth, not having a red light for 1 minute and wait for the next road to pass. If there is no cars, you can switch quicker, for example. So this is typically what we see more and more growing around in the world. From SmartMicro side, they are selling quite a lot here. And they have been very fond of our technology and see that they can have a lot better view, and also not at least the range for a radar to really detect on long ranges. So they see this very important to go from what they have today, PCB-based antennas, over to waveguide antennas from Gapwaves. So it's a very good and interesting collaboration we do have with SmartMicro in this area. And they are one of the more successful in the area of doing this kind of equipment. We were, my CTO and myself, over in US recently and met a number of customers and also present customer or prospects, as we call them, both in Austin. There we have one customer called Under. They have been doing a radar chipset for the last years. It's a very competent radar supplier, I would say, and they uses our antenna in their solutions to the customers. So we met them first, but then we all continued to San Francisco and was in a conference called Autotech Council in Mountain View in San Francisco, and met a number of customers around there. It's really of interest to see what they are talking about. All of them really wants to be more and more into what they call autonomous driving or cars, which could be like a robot taxi. I will soon show a picture or a small video here. It's a Waymo taxi we understood was working, and it's 2 colleagues of us working or being visiting Phoenix in this case, that they use these cars today. It's interesting to see that this is reality. It's not what only us talking, it's happening at the moment. And also there were typically what they all talked about very much was they needed better radar solutions, and the key for solving that is really about having a better antenna. I was very happy after this week that we could really conclude that the same wording came from a number of very strong companies in this area. Let's see now if we can run the film here. As you can see, there is no driver in this car, and it's a taxi in Phoenix. So now it's turning, and there are two colleagues from Business Sweden sitting in the back seat in this car. The only thing you see is the map. And the car is doing its work by its own. Typically, we see that this happen in small areas that they start in US, and then they are trying to grow their business in different directions, like, yeah, mostly geographically to get into new areas to really test the solutions with, for example, this kind of taxis or more places. And it's not only Waymo, it's Zoox. They will be in Las Vegas the coming end of this year, and they will start to really run the taxi solution also there. Aurora, for example, is more into what they work with the solution for the autonomous driving and sell that system as a driver, both for trucks, but also for customers like they work together with FedEx on trucks, but they also work with another company called Uber, you know about them, in the area of taxi. So they will start with some prototyping, running some taxis in different places without drivers as well, coming, I guess, in the beginning of next year. So this is happening, which is, of course, very interesting. And knowing that all of these companies really very much are looking for our kind of technology is, of course, very interesting. Another part we have been doing and released things about now the last month here is also production equipment or testing equipment for production. This is the first testing solution which will be now delivered to our partner Franken Group in Malaysia, China. They will produce the first volumes for coming out to Hella as our main customer in the automotive radar systems. This will be starting next year, but the equipment is now ready and shipped to the customer. So I will also run this so you can see what is happening when we test an antenna. On the belt here is the antenna coming in from the production line, and then it will be started with the testing here in what we call an XY table on the right side. And it takes around 5 seconds per antenna to be tested. And then it's, in this case, 7 different channels you will go through. And this is high-speed testing on 77 gigahertz. I don't know if everyone understands, but it is quite a challenging thing to do in this tempo and has not really been done before. So I think this is a good step for us to help our producers or suppliers to really become efficient on high volume production, which is a need in the automotive industry. Okay. Summarize a little bit about the customers. There are license agreements which we have released already with Hella and Veoneer. We are working with a number more, both automotive tier ones, but also on global tech company and some other radar verticals. These things are going on in parallel. We are talking very much with the technical stuff and do the development of different antennas. At the same time, we have a commercial discussion, or not just discussion, it's a negotiation, I would say, more to come to agreements with more customers, of course. And as no one has said no, yes, it's quite important that we continue that path, and we see absolutely a nice future coming up on this area. On the telecom, we have delivered some 28 gigahertz evaluation platforms, which also works very well. But so far, there has not been really any big demand or need for this kind of equipment from our customers. But so far, we have delivered, coming back to radar antennas or imaging radar antennas, over 20,000 pieces of 77 gigahertz corner and other high resolution radars antennas from here, from Gothenburg. We buy pieces from our suppliers and put together and do the assembly here, but also deliver directly to customers after this test station has done its job. So that is ongoing, and the numbers will, of course, grow over time. The business focus this year is very much about, as you can understand, coming into more of these long-term agreements with big customers. So we make our future as good as possible, of course. That's absolutely our goal. We will grow into new verticals, as you can see and understand from the presentation as well. Typically, we see robotaxis, etc., and also trucks could be a nice area for this kind of imaging radars or our antennas in the radars. We will produce antennas as one part. Specifically, these imaging radar antennas will be something we will produce and deliver. We do it already, but we have a capacity coming up to 150,000 units per year. That will be in our, so to say, goal for the year. That means also that we still and will continue to explore the possibilities in the telecom segment and also maybe the Satcom, which has been also opened up a little bit. We are involved in some research projects together with other companies around in Gothenburg, not only in Sweden, but also outside, and also with the Chalmers University here. And we see that the potential for the technology could be that this absolutely could be standard within this mmWave area of antenna of equipment for radio frequency stuff. I'm back to the last slide here. Why should you invest in Gapwaves? Yeah, if you believe in the mmWave area for this kind of equipment coming in on higher frequencies, and that will happen. Gapwaves really have something which is unique and something most customers absolutely both want, but also are in need of to really produce their equipment. So we are a market which is mega trends, I will say, very global company. We are not having more than one customer in Sweden. Elsewhere, they are outside Sweden, all of them, I would say. There is a patented technology, which means that we have some security not being copied, but of course that's also challenges over time. We are in the area of high volume, production, and that we now can show that this will work. To produce one corner radar per 5 seconds would be quite a lot over 1 year if you go for one line only, but this will happen, and we can absolutely be able to be in the lines for up to many millions per year deliveries. So that is really the span of what we are doing, and I think so far, looking for the competition, Gapwaves really are in a unique position and a very strong position. Thank you.